CO2, Luca, Evelyn, yeah. Which already went through this one objective of geometry. Get back to algebra here. And what we're doing is we're finding segment length and determine if two segments are congruent. So segment length, that was the one thing that we said yesterday could be measured. This is the only thing that had a beginning and an end. Okay, and today we'll be using algebra, setting up equations to help us solve this. And the word congruent is one you probably know what it means. What does the word congruent mean? Anyone want to? Anyone? Not complementary. The same. Okay, and we say the same. It is the same size and shape. Okay, same size and shape. And there's a difference between congruency and equality. Okay? Because congruency just means they look the same. Equality means they have the same value. For example, a $1 bill and a $5 bill are congruent because they're the same size and the same shape. Are they equal? They're not. They don't have the same value. So when we talk about figures and shapes, things like that, segments, we use the term congruent. Okay? Sometimes we can then make the leap to equality, but I need you to remember congruency has to do with things. Equality has to do with value. There is a difference between those symbols. The congruency symbol, as you can see, is an equal sign, but it's got a little thing over it. Okay? When you see that, it means congruent. It means they are the same size, the same shape. In this case, it means they'll have the same measure, but it means that things are the same versus value being the same. Good. Question? Okay.
What's the swivelly thing mean?
Oh, James.
Oh, James.
That
I mean,
means it's congruent.
No. I mean, why is it there?
To tell you that it's not equal, that it's congruent.
So, but who thought of it?
That I don't know. That I don't know.
It just doesn't make sense. Why did they just put a swivelly line?
Gotta put something. I
Just
don't
put
know.
an extra
What do you
line.
think would be better, James?
Okay.
An extra line.
James, when you're a mathematician, you can make your own symbols.
Thank you. Yes.
Wait.
The first postulate that we're going to talk about, these are things that you will need to commit to memory because we will use them in, when I say commit to memory, you need to have them in a place that you can access easily because we'll use them for proofs, we'll use them in your postulates and theorems quizzes, but these are kind of the geometric rules, the rules that govern geometry. In algebra, the rules that govern algebra, PERMDAS. Okay, it basically all boils down to that. Geometry has a lot more things. And what segment addition postulate says is the parts of a segment will sum to equal the whole segment. Okay? The parts of a segment will sum to equal the whole segment.
Isn't that true for anything?
We also have something called the angle addition postulate and the arc addition postulate. So
We
yes,
have like a pizza, like all the parts of a pizza.
the pizza addition postulate. Yes, we have that too. Okay. So for example, if you have a segment that is divided into two sections, where one of them is 3 and another is 5, what this postulate is saying is that you can add 3 and 5 together to get the entire length of the segment, which would be 8. Okay? Now, you've done this before, right? You've added segment lengths together, measured things, and everything. You didn't know what you were doing geometrically. What you were using is called the segment addition postulate. It allows you to do that. Okay? Questions on the notes? Tatum, did you figure out what you were thinking, or are you all good? Okay. Okay. So here's how we can use this. It says find the segment length, and when you see this notation here, without the segment bar over it, it's talking about the value of, the measure of. Okay? If you saw GH with the segment bar over it, this refers to just the segment, the thing, the segment as a thing. You see it without the bar over it, it still means segment GH, but it means the value of it. Okay, again, notation is very important. You have the segment, the thing, and you have the value of it. Okay? I'm holding a $20 bill, the value is $20. Right? A little bit difference there. So, in this first one, we see that F to G is 21. Notice how this 21 is kind of in the middle of it? That's how you know it's talking about F to G. It'll be in the center, or as close to the center as you can make it. Okay? This 36, notice how it's in the middle of F and H. It's also got kind of those brackets there. That's how you know it's talking about from F to H. So if from F to H is 36 and F to G is 21, what would G to H be?
15.
15. Why? Because 21 plus 15 equals 36.
Or 36 minus 21.
Or 36 minus 21 is 15. Hey, fact families, remember those from back in the day?
No, what
Okay.
about
It's algebra, you just subtract.
Alright. The next one, we're looking for the value. Again, no segment bar above it. Means we're talking about the value of, not the thing, but the value. The value of Wx from V to X is 144. Again, notice the 144 is in the middle. It's got the brackets. Told you it's the entire thing there. V to W is 37. 37 is in the center. What would Wx be?
107.
107. Why? Because 37 plus 107 is 144. Or 144 minus 37 equals 107. So far, so good.
Yes.
Any questions?
No.
Okay. So, here we go. Point B is between points A and C. I will recommend this several times during the course of the geometry here. Drawing a picture is very helpful. Visualizing what you have here. It says point B is between points A and C. Do we know if B is closer to A or closer to C?
No.
We don't. We don't really care. Okay? We're just drawing a sketch of segment AC, and point B is somewhere in between them. Okay? Then it says that from A to B is 2x plus 7. Okay, from A to B is 2x plus 7. Again, notice there's no segment line over AB, so it's talking about the value of it. And it's also using an equal sign, right? It's talking about value here. From B to C is 7x minus 8. And from A to C, so we're going to use those brackets like we had on the above examples there. From A to Z is 80. And our job is to find the measure of AB and find the measure of BC. Using the segment addition postulate, what is an equation, and we're talking about algebra here, because algebra is all about equations. What is an equation we can set up that will allow us to solve for x and ultimately get the measure of AB and BC? Priya?
I don't know.
Oh, you're waving at me? Oh, hi. Evan?
Could you do, like box? What?
The box method?
Yeah.
So if we were multiplying them, yes, but remember this is the segment addition postulate. This section plus this section equals the whole thing. This part plus this part equals the whole thing. So what would we use instead of multiplication?
I don't know. I know what addition. Oh, addition.
Addition, right? So 2x plus 7 plus 7x minus 8 equals 80. Right? Part plus part equals whole. Part plus part equals whole. 80.
That's the only way to solve this by guessing in a second.
No.
Can you combine
We have an equation.
Oh, wait, so.
We have an equation. Okay?
Can you just combine it?
Yes. 2 x's and 7 x's is how many x's? 9 x's. Positive 7 and negative 8 make what?
You won.
Negative 1. So 9x minus 1 equals 80. Pretty basic two-step equation.
X equals 9.
X equals 9. Now one trap that you don't want to fall into with geometry is thinking that solving for x is your answer. Usually in algebra it was. Solve for the variable, solve for the variable. The question is find a, b, and b, c. If x is 9, how do we use that to get a, b? You go.
Plug it back in.
Yeah. 2 times 9 plus 7 is what? 25.
Potato.
7 times 9 minus 8 is what? 55. Do 25 and 55 add to make 80?
Yes.
Yes, they do. So it's easy to check it here, right? Ella, you have a question? Chris, okay. Any questions on what we just did? Yes.
If I ace the next
No, not around there.
next test, no,
Okay.
I would test it.
Schultz, are you supporting gambling?
Yeah. Yes.
How so?
Because you're gambling with the new scout on his next test.
No, I said not now. I shut it
Yeah,
down.
not now, that doesn't.
Next one, point B is between points A and C.
That means later.
Again, we're going to start with a segment.
Big ol'
We don't know where B is. We don't really care. Somewhere between points A and C is the only information that we have here. AB, that value is 6x plus 12. BC, that value is 29. And the whole thing from A to C, that value is 19x plus 15.
What? What do you mean? Simple equation. Simple equation, Luca.
19.
Oh, okay.
And again, what the segment addition postulate tells us is that a part plus a part equals a whole. So, in this case, we have 6x plus 12 plus 29 equals 19x plus 15. The part plus the part equals the whole. What?
Shouldn't we be subtracting because that's like the whole, because the 19x plus 15 is like the whole thing.
What?
And the 6x plus 12 is just part of it, so should we be subtracting?
Right. This part plus the other part equals the whole thing. Okay? So, combining like terms again, we have positive 12, positive 29. So 6x plus 41 equals 19x plus 15. We have a variables on both sides situation here. Aiden?
Can I say what x is?
Sure.
It's 2.
It is 2. Move the 15 over to give us 26 over here. Move the 6x over to get us 13x over here. And 2 equals x. Aiden, is that our answer?
Of course.
So we're done?
No.
No. What do we do with this?
Stop, hold, stop.
Calm down.
What's 4, right?
Stay still, gang.
Yeah, you.
Wait, so I'm, wait.
Can we do the actual
15.
Really?
Yeah.
Yes.
Subtract 15 from both sides.
Oh, that's good.
Subtract 6x from both sides to cancel this out over here. Cancel this out over here, right? There's it's variables on both sides of the situation, opposite operations. So subtract 15 from both sides to move that to the left. That gives us 26. Subtract 6x from both sides to move that to the other side. That gives us 13x. And from there, you're dividing 26 by 13 to get
I
2.
see what I got it. Just with an extra step. Wait.
Not no sense.
Hey, it's just multi-step equations.
We
Correct.
learned this in pre-algebra.
Correct.
Really does.
So, bottom, does the bottom equal 53?
Wait, why are you crossing out?
We learned this in math.
Because 6x minus 6x equals 0x.
Congratulations, you have to see what I call it.
I'm subtracting, I'm using opposite operations to subtract it. from one side to move it over to the other.
Yep, I got the.
Remember, variables on both sides, you're gonna get all your variables on the same side. So we're using opposite operations here. So if x is 2,
24, 29.
6 times 2 plus 12 is 24.
Alright.
And 24 plus 29, this should equal 53, which 19 times 2 plus 15 does.
Hey, hey, hey.
I
Okay.
hate this.
You were just saying how much you loved it yesterday.
No, I thought I liked geometry.
I hate this.
Your assignment.
This isn't
It's
geometry.
this last one that looks like.
Nope, not the last one. It's from your book, if I can find a
We don't have to
book.
do the last one. Looks like
No, you don't have to do the last one.
Thank you, brother.
I am not doing the last one.
So this should go in your assignment notebook. You also write it at the bottom of the page here where it says keep calm and do your homework. On page 12,
Oh, I went to 300.
Oh, well.
What?
on page 12, you are to do 6 through 11.
Whoa.
Whoa.
Yeah, what?
Wait, what am I down?
Oh, that's simple.
On page 12, 6 through 11,
Guys, look at me.
That's the simplest thing I've ever seen.
comma, that means there's more. 21 through 26,
Do we write down the answer?
Oh, I hate this.
comma,
What?
and 28 to 30.
Guys, are you even reading the pages?
Yeah.
It's not that big.
Okay?
yourself.
We just do it in like.
Where do we write this on this paper?
You can do it on the back side of your binder sheet. You can do it in a notebook, whatever you want. They are single-sided sheets for this
Like,
reading
do
here.
we write the answers?
It's been a while since you've done math homework from a textbook, but yes, you write the answers
Ben,
down.
not
I've never done it from a textbook.
Like in 5th grade?
Oh, yeah.
We did one-sided sheets every
Oh yeah, workbook. I got